Hello students, in this semester I'm going to teach you Unit 5. The first topic of Unit 5 is nothing but the location of the root of fx. In order to find the root of fx, I'm going to use two methods, that is the bisection method and the Newton approximation method. So these two methods will help us to give the approximate root of any function. Okay. So first of all, to do these two methods, I'm going to explain you what is the intermediate mean value theorem. So according to intermediate mean value theorem, a function f is continuous in the closed interval and fa and fb are of opposite sign. Okay, they are of opposite sign means one fa will be either positive or negative. If fa is positive, then fb will be negative. So they are of opposite sign. Then we can find one element between a and b. Suppose I take the element as c. So we can find c belongs to ab such that f of c should be 0. Then c is called the root of fx. Okay, so I'm taking a continuous, I've explained you with diagram about the intermediate mean value theorem. So I'll take a continuous function first, but the main thing here is that fa and fb are of opposite sign. Okay, fa and fb are of opposite sign. So I'll take fa as negative and fb as positive. So if I take fa is lying below the x-axis, means this is your, suppose this is your point a, this is your point a, and this is your point b. So this distance is nothing but fa. So this point I'm taking as fa. Okay, and at this point this is nothing but fb. And you know that the curve, that the function is, we know that the function is continuous. So you draw a continuous curve from here to here. So by any possibility, at least at one point it will cut the x-axis, and the point where it cuts the x-axis is nothing but the root. So this point I'm donating as c. So c is lying between a and b, and we have here that is nothing but f of c is equal to 0. So c is called the root of fx. Okay, so next I'm going to explain you what is the bisection method. So bisection method is depending on the intermediate mean value theorem. So we have here, this method is used for finding the root of fx. So in this method we'll start with two approximation, means I'll give you two approximation a and b. So I have to start with two approximation a and b, okay, such that fa into fb is less than 0. That means one is either positive. If fa is positive, fb will be negative. So they are of opposite sign. Okay, then that is the root of f lies in ab, means we can find one value between a and b. Okay, square root between interval a and b. You can always find one value between a and b such that such that fc is 0. Yes, if c is a point lying between a and b, then fc will be 0. Okay, so how to proceed with this method? So suppose we have, this is your interval ab. So this is your interval ab. Yeah, so what we are going to do, we know that the root lie between a and b. So how to, we are trying to, in this method, what we do, we try to find a point c by taking the average of these two points, or we'll try to find the middle point of a and b. So you will try to find the middle point. So suppose the middle point is donated by c. How do you find? This will be found by a plus b divided by 2. Try to take c equal to a plus b divided by 2. Now then we'll try to, after finding the value of c equal to a plus b by 2, you try to find what is f of c. By chance, if f of c is 0, then c is the root. But if fc is not 0, then c will not be the root. So we'll get two intervals. We are getting two sub intervals a and c, and C and B. So we get two subintervals. So we have to take one subinterval here. So how to choose a subinterval? We are going to find what is f of c. So for example, if I take f of a is positive and f of b is negative. Okay, if I take f of a is positive and f of b is negative. Okay, if I take this, then if the value of f of c is negative, then the value will be lying between a and c. Then the root will be lying between a and c. So you try to take try to find the middle point between a and c. Suppose I donate by d. So how I'll find this? This is nothing but a plus c divided by 2. We will try to find what is f of d. So f of d will be, if it is 0, f of d is 0, then d is the root. But if f of d is not 0, then d will be not the root. So again, we'll try to find, if f of d is not 0, suppose if f of d is not 0, then we are getting two subintervals. One is a to d and d to c. Okay, so this subinterval we are going to proceed further. So we have to check. So this is f of a is positive and f of c is negative. Now if I get f of d is positive, for example, if I get f of d is positive, then we'll replace a with d. So now we'll try to take this subinterval. We'll try to take this subinterval dc, and we'll try to find, because we know that the root is lying between d and c. So we using this subinterval d, we'll further subdivide it, and we'll try to find another point e in the way d plus c by 2. D plus c by 2, and we try to check if f of e is 0, then e is the root. If f of e is not 0, then e will not be the root. So if we don't get f of e is not 0, then we proceed in the similar manner as we have done before. So this process is nothing but is called the bisection method. This method is nothing but the bisection method. So I have taken one example here. So we have taken solve x cubed minus 5x plus 1 equal to 0. By bisection method, take 3 decimal places, means we'll take 3 decimal places in your calculation and find the root obtained in 3 iterations. So we are going to obtain the roots in 3 iterations. So first of all, we have to give the initial approximation. So I have to give the 2 approximation roots. So here I'm taking x0 because they have not given you, so you have to choose by yourself. So I take the 2 approximation. I took x0 and I find what is f of 0. So I got 1. 1 is positive, so this is f of 0 is positive. And x1 is, I took as 1 and we try to find, and we get negative. So we know that the root of this function fx is lying between 0 and 1. And here we are taking the function as x cubed minus 5x plus 1. Okay, now we know that the root of fx lies in 0, 1. So we'll try to find a middle point of these two interval. Okay, we'll try to find a middle point. So how we'll take x2 equal to x0 plus x1 divided by 2. So x0 is 0. So we put here 0, 0 plus 1 divided by 2. So 0 plus 1 we get 1. 1 by 2 is nothing but it is 0.5. So we get this point. Now we'll try to find what is f of 0.5. So here f of 0.5, we got here minus 1.375. So this is negative. Okay, now this x2 will be replaced by x1, because in x1 also we got negative. So this x2 will be replacing x1. Okay, so in place of x2 you put as x1. Now the root, okay, the root will be lying, because we got negative and f of 0 is positive. Okay, f of 0 is positive and f of 0.5 is negative. That means the root is lying between 0 and 0.5. So we'll take x0 as 0, x1 as 0.5. Okay, and we'll proceed in the similar manner. X2 will be equal to 0 plus 0.5 by 2, which is 0.5 by 2, which is 0.25. So we'll try to find what will be the value at this. So here we get us, see here we get what, f of 0.25. We got here minus 0.234. We are getting here minus 0.234. So which is negative, okay, and f of 0 is positive. So the root will be lying between f of 0 and f of 0. It will be lying between 0 and 0.25. The root is lying between 0 and 0.25. Now you take x0 as 0 and x1 as 0.25. Okay, so again you find x2, so x0 plus x1 divided by 2. So we get here 0 plus 0.25 by 2, we get here 0.125. We try to find again the same, so we get here 0 plus 0.376, 0.376. So this is positive, okay, and f of 0.25 is negative. So the root will be lying, okay, the root will be lying between 0.125 and 0.25. Okay, so the root of fx lies in 0.125 and 0.25. Okay, so you can take x0 as 0.125 and x1 you can take as 0.25. Then find x2, so we have x0 plus x1 by 2, which is equal to 0.125 plus 0.25 divided by 2, we get 0.375 by 2. You divide this one, we get 0.1875. So we have here 0.071. Okay, so I have proceed. I've done 4 iterations. So if after doing 4 iterations, you can stop the procedure. If you are not getting 0, also you can stop the procedure. So the approximate root of this function fx is nothing but it is 0.187. Thank you.